quadratic systems. So today we're looking at quadratic systems. I want you to make a note that we have 3 days of instruction before the next test. Okay? So we got 3 days of instruction, a benchmark in the middle, and then review test. Then we have one more test left before semester exams, and that test will be when we come back from Christmas break. So this unit's short and quick, but the next unit is longer, has more stuff in it. Okay? All right. So those of you who love, like, doing the calculations, the algebra stuff, you should enjoy today. Those of you who love graphing, Tuesday will be graphing. So there is something good for everyone. All right. So look inside the box. It points out that a solution to any system is this. Are we ready? The solution to any system is the set of points shared by the equation. So your solution, the answers have to be points. That means they have an x and a y value. Okay, you can't just find the x and be done. You have to have x and the y value. We're going to use elimination and substitution both. When you're doing your actual work, you can use whichever one you like, but you should be able to see how both of them work fine. Okay, first let's look at graphs. If I have two parabolas in the system, and I'm looking to find the solution, which is the set of points shared, then I know I'm looking for the intersection points, right? So how many solutions could two parabolas have? How many times could they intersect? What are my options?
One.
Okay, so we got one solution. That is definitely an option. Let's look at that graph. Here would be, say, a parabola. The other parabola would just kiss. Remember what that's called? There'd be tangent. It'd just be meeting at that one point. One solution is definitely an option. What other options? Infinite solutions. Let's look at what it would look like for two parabolas to have infinite solutions. Here would be one parabola. Here would be another parabola. So they could be coincident, which means they are in the same space. They are exactly the same parabola. There could be infinite solutions. Well, let's look in between. Could there be two solutions? Yeah, let's look at what that looks like. I could have one parabola here and the other parabola here. That would be two solutions. Okay? So is that the only options? What about zero solutions? Is that possible? Yeah, so I could have one parabola here, and I could have the other parabola down here. Okay? We're also going to be looking at systems that have one parabola and one line. Okay, so we're going to explore. Can it have no solutions? Can it have one solution? Can it have two solutions? Can it have infinite solutions? All right. Which one of those you think is going to be possible? All of them? No. Which one you think's out? Yeah, you can't have a line and a parabola that share every point. That would be impossible. So to have zero solutions, we might look like this, right? To have one solution, again, we're looking at that tangent where the line just kisses at one point the parabola. And then two solutions, I think is pretty clear. You could see would be what we would normally expect. Two solutions. All right, it's pretty good. So we're going to solve algebraically for those intersection points. We're going to do it first with substitution. So I wrote that in right here. If both equations equal y, then you can use substitution by setting the two equations equal to each other. So here I've got two equations, both equal to y. So I know that this is equal to this. So we're going to say x squared minus 4x minus 2 equals negative x squared plus 2x plus 6. And we're going to set, notice the y's gone now. So we can set it equal to 0 and factor to solve for that intersection point. So I'm going to add x squared to both sides, in which case I'm going to get 2x squared. I'm going to subtract 2x from both sides, in which case I get minus 6x. And I'm going to minus 6 from both sides, in which case I have minus 8 equals 0 on the right. Okay? So now we're ready to factor. Can I simplify this equation so it'll be easier to factor? Yes. Yeah, I can divide the whole thing by 2, and I get x squared minus 3x minus 4 equals 0. So I'm looking for the factors of negative 4 that add to be negative 3. What do we think?
Negative 4, 1.
Negative 4, positive 1. So we've got x minus 4, x plus 1. Okay. And my solutions then will be x equals 4 and x equals negative 1. Those are the x values where these two intersect. Okay? But we're only halfway there. We need the y values. So we're going to take the original equations, either one, doesn't matter which one, and we're going to plug in the x value to get the y that matches it. So I'm just going to use the top equation. So y equals, plug in 4 squared minus 4 times, plug in 4, minus 2. So y equals 16 minus 16 minus 2. 16 minus 16 is 0. 0 minus 2 is negative 2. Okay? We're going to plug in the negative 1. Y equals negative 1 squared minus 4 times negative 1 minus 2. Use parentheses to make sure you don't lose those negatives, okay? So y equals 1. 2 negatives make a positive 4 minus 2. 1 plus 4 is 5. 5 minus 2 is 3. Okay? So how was that? It's good, right? Especially if you like doing algebra. If you don't, well, you get to do it anyway. All right. So we're going to put these two equal to each other. We've got x squared minus 4x minus 1 equals 1/2 x minus 6. I don't really care for a fraction. How could I get rid of that 1/2? Multiply the entire equation by 2. We get 2x squared minus 8x minus 2 equals x minus 12. We want to put the equation, the parabola, equal to 0. So I'm going to subtract x from both sides, and I'm going to add 12 to both sides. I get 2x squared minus 9x plus 10 equals 0. All right, this one's a really good factoring refresher. I cannot factor it with the 10 because of that 2 at the beginning, right? So instead of looking for the factors of 10 that add to negative 9, I'm looking for the factors of 20 that add to negative 9. Awesome, negative 4 and negative 5. So when you put it in the parentheses, again, you have to be careful because of that 2. So we've got 2x times x. Those two spots will multiply. So I've got to divide the negative 4 by 2, and I put a negative 2. These two spots will multiply. So I just put in my negative 5. Okay? All right, so my solutions are x equals positive 5/2, x equals positive 2. Even though there's a fraction in the second equation, it's going to be a lot easier than squaring the fraction and then adding it to a fraction. We're going to use the second equation, okay? So we're going to plug in the 5/2. Y equals 1/2 times 5/2 minus 6. Hopefully you recall, multiplying fractions, you multiply the top and the bottom. So y equals 1 times 5 is 5, 2 times 2 is 4. And if I'm going to subtract 6, the 6 also has to have a 4 on the bottom. How could I rewrite 6 to have a 4 for the denominator? Say what?
24 before.
I'm going to multiply top and bottom by 4, and I get minus 24 fourths. So 5 minus 24 is negative 19 fourths. Seem good? One of our real goals for this year, for your TSI, for your college algebra class, for your pre-calc class, whatever you're doing after here, is to get much more comfortable with adding and subtracting, multiplying and dividing fractions. All right, the 2 will be easy to plug in. We've got y equals 1/2 times 2 minus 6. What's half of 2? 1 minus 6 is negative 5. Seem good? All right. All right. If everything goes well, we can skip the last example, but we're going to need to do all 3 of these, okay? Am I going to be able to work with those 2 equations the way they are? I'm not. I'm going to have to spread this out into standard form. So remember, this is a really important point, that negative cannot go inside the parentheses because it has a squared on it. So I'm going to leave the negative outside. I'm going to leave the Becky 2, oops, there at the end. And I'm going to FOIL out x minus 6 times x minus 6. So we've got x minus 12 plus 36. Okay, feel free to use the pattern. I know if I've got x minus 6 times x minus 6, minus 6 plus minus 6 is the middle. Oops, except for I forgot the x. Man, Miss Mendez. Okay. Distribute the negative. Negative x, I forgot the squared. Nobody said a word. Plus 12x minus 36 plus 2. These last 2 have to come together. So we've got y equals negative x plus 12x. Negative 36 plus 2 is negative 34. What do you notice about those 2 equations? Sorry. Who said that? Eva, thank you. All right. What do you notice about the 2 equations? Say what? They're the same. They are going to be in the same space because they're the same parabola. So how many solutions will there be? Infinite solutions. If I were to put them equal to each other and do the math, working the way down, I would end up with 0 equals 0, which is true always. Infinite solutions. Seem good? All right. We're going to look at now we're going to look at elimination. So again, you can pick which one you like best. I like elimination. If we're going to eliminate the y's, what do we have to do to one of the y's? We have to multiply by a negative. Let's multiply this entire equation by a negative. Okay? We're going to get negative y equals positive x squared minus 2x plus 1. And for elimination, I'm going to put the 2 equations right on top of each other. And I'm going to combine, going straight down. The y's cancel out. I have 0 equals 1x squared plus 1x squared is 2x squared. Negative 2x minus 1x is minus 3x. 1 minus 6 is negative 5. I love elimination. I think it's much cleaner, like you're right there. All right, we can't divide in order to simplify that 2 at the beginning. So remember, we're going to multiply 2 times negative 5. What are the factors of negative 10 that combine to be negative 3? 2 and negative 5. Negative 5, positive 2. So we've got 2 parentheses equals 0. 2x times x. These are the spots that are going to multiply. So I'm going to put plus 1. These are the spots that are going to multiply, so I'm going to put minus 5. So my solutions are x equals positive 5 halves, x equals negative 1. And what do we got to do? Plug it in. Both equations are about the same, so I'm just going to plug into the first one. Okay, plug in the 5 halves. So y equals 5 halves squared minus 5 halves minus 6. Y equals, to square a fraction, square the top, square the bottom. 25 fourths. I want this to have a matching denominator. How will I rewrite 5 halves to be in fourths? 10 fourths, multiply 2 over 2. So we got 10 fourths. What will I do to the 6 to get a 4 for a denominator? Right? Multiply 4 by over 4, so 24 fourths. So I know my answer is going to have a 4 on the bottom. I just have to do the math on top. 25 minus 10 minus 24. So 25 minus 24 is 1. 1 minus 10 is negative 9. Now this negative 1 will be easy to plug in because that one was, so we got negative 1 squared minus negative 1 minus 6. So y equals positive 1 plus 1 minus 6, negative 4. The process seem fine? Seem good? Fractions seem okay? This last one, we just have something important to see about it because it's not going to be factorable. Okay? So we've got to distribute this out. So just like before, I'd like you to save the negative for the last step. We're going to have x squared. These add, so minus 5x. These multiply, plus 6. Distribute that negative, negative x squared plus 5x minus 6. These are the two equations we're going to be using. You pick. Substitution or elimination?
Elimination.
Elimination. When I move this equation down here, I'm going to multiply it by a negative 1 so I can eliminate. So negative y, line up what belongs together. Minus 2x goes all the way over here. Minus 1. These are the two that I'm combining. I've got 0 equals negative x squared plus 3x minus 7. I do not like a negative a value. So I'm going to just multiply all the way through by a negative 1. Still have a 0 equals x squared minus 3x plus 7. All right, factor. Factors of 7 that add to negative 3. Is it going to happen? No. So I give up. Do I have a tool that I could use when I don't know how or it's not able to be factored?
Quadratic formula.
Thank you. You're the first class all day that said that. Good job. So we got A equals 1, B equals negative 3, C equals 7. Circle B. X equals negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. Take a quick look at mine and make sure you put the same in. It should be positive 3 plus or minus the square root of 9 minus 4 times 1 times 7. Okay, before we go on, I want to ask you a question. What type of solutions? If I look inside here, what is this number inside the square root called? We just, the discriminant. So we have options. We could have one real answer, we could have 2 real answers, or we could have 2 imaginary answers. So it could go one of 3 ways. Okay, let's see what's inside here. 9 minus 28 is negative 19. So my discriminant is negative 19. What kind of solutions do I have? 2 imaginary. If the 2 intersect, they have real solutions. If they don't intersect, then they have imaginary solutions because you'd have to imagine it because it doesn't exist. Okay? So because there are no real solutions, we know that there are no real solutions. We don't have to go any further. When we see that discriminant is negative, giving us 2 imaginary solutions, we know the graphs do not intersect. Okay, do you want to see the last example? How many people would love to not be here this afternoon? But we are. Our homework is on the iPads. And just think, the people who are gone are going to have to get caught up, and you'll be on top of it.